Perfect. Good morning. Hello, David Headley. Excuse me. This is your. I'm not seeing that. Sorry. Good morning. This is my contribution to our pandemic lockdown. Um, Tried to make the timing workable. I realized I may have gotten a little on this a little soon. Some of my brethren are busy right now trying to work through VPN solutions to get their staff working, or maybe doing circuit upgrades. As a network designer, well, I've got plenty to do. It's just there's nothing that's immediately going to impact this. So I have some time on my hands. These recordings are going to be put up on my YouTube channel, so you can do it. They're replacing an older series. I've improved the content after spending another almost 2 years now playing around in Multicast, making it work, making it successful. So I've improved the content, and I'll be deleting the older content as soon as I have it replaced with this new content. Feel free to ask questions along the way. I know I have the audio muted, but you should be able to send chat messages, that sort of thing, if you have anything you need to share, any questions. So there'll be a little bit of repetition, and we're going to break at half an hour so I can keep these in a little more manageable chunks. I was doing an hour plus before, and I think people just didn't, an hour, sitting down for an hour video is a long time. That shorter is better. So we're going to do that. There'll be a little repetition. Let's get going. First, my background. Here's a slide. I got all kinds of Cisco credentials. I have a few other things that aren't on this chart, some of them that aren't current. Seriously not current. And if you want to check out all my current badges, there's my claim, how to find me. You can see all the different things I'm current in. And this includes both wired and wireless. And I've been spending the last 5+ years designing, building, and supporting multicast networks, IPv4, to be clear, although we'll talk a little bit about IPv6. Whatever brands that are models are for illustration purposes only. I'm not endorsing them or saying that, they're the only things that work, or that, depending on particular code licensing versions, you may need to make some changes to get even the gear. If I illustrate particular gear, to get that to work. This is not endorsed by Cisco in any way, at least not at this point. I'm welcome to get a gold star from Cisco, sure. This is not representing a business process of any employer or client, past or present. Is based on my own work and study. So I only include equipment I have experience with, and that includes even with IPv6, right? I do have some experience with IPv6, not a lot, because a lot of companies are still hesitant, okay? And at this time of writing, I've not received any compensation or inducement from any vendor. So Cisco's not giving me anything at all. Sad face. Yeah. What's multicast? Group communication, that's it. So the original problem is addressed in RFC 966 was he wanted to do something other than broadcast or set up a bunch of unicast streams to be able to replicate to multiple machines. So came up with the idea of multicast. 966 doesn't look a lot like what we see now, but you can see the real foundations of it. It was replaced a year later, and then there's been a number of revisions since then, and a lot of added functionality and capability. I like to give you a focus. So for this one, we're still working on fundamentals, and this is we're going to look at how does this thing work on a local LAN. And you may say, but I already works on my local LAN. If you're running OSPF, RIP version 2, EIGRP, that there's already multicast traffic on your network. It's not routed multicast traffic, it's link local. So in a sense, it's happening at the layer that we're seeing here, but there's a lot more to it. Those things have a TTL of 1. They never get through a router. They stop at the router. They're destined for the router. So let's keep going. I always mention this. You have a 3-legged stool on all your projects. If I want things faster, it's probably going to cost me more money, or I got to jettison some of my scope. If I want higher quality, it may cost me more money. It may take me longer, right? That simple. I like to emphasize that. This is a great thing to go back when your leadership has said, hey, you're doing this big multicast deployment and I need you to do it in a third of the time. I'm like, wow, okay, so something's going to give. And this is my illustration to really say what's the point of multicast. In a large routed network where you're routing multicast, the idea is any single link only carries one copy of the traffic, no matter how many receivers that are on the other side of the link. So when you see a router in here, and on the far side of this link, he's got 3 receivers. In multicast, he only needs to take in 1 copy, and that's going to have a direct impact on bandwidth. And this is an illustration of what that means. So from the sender's perspective, one stream, so whatever the link out of the original sender, the original source, we're going to use the word source a lot, that source, that's his bandwidth is absolutely flat with multicast. With unicast, well, I got to create a new stream every time. So if I have a busy cluster of presenting streaming video, Facebook, something like that, even Zoom, because it's unicast, every additional listener, every additional viewer adds to bandwidth. Okay, there is in IPv4, there's a distinct range. IPv6 as well, but in IPv4, distinct range, it's Class D, remember your classful networks, which you still get tested on. It's still sort of relevant, and if you're running RIP version 1, it's incredibly important. And there's some things in IGRP in that are relevant, even in OSPF, that are relevant, at least on Cisco, for classful. So you do need to know that. The Class D, 224 through 239, and then when you break it to binary, you're going to see it starts with 1110. So that's all repetition. There's the new stuff. Here we go. So Internet Group Management Protocol. This is how a host tells routers about group memberships. Now, routers can do queries, and they can solicit members from the hosts on an interface. And this is how the router knows someone wants traffic for this group. So if it's just a local LAN, IGMP is in play, but IGMP isn't necessarily all that important. So what's going to happen with this is that a source, a sender, doesn't even get involved with IGMP. It just starts sending traffic to that group. As we saw in yesterday's talk, there's a specific MAC address. If it was on a LAN, on a hub, right, like the old thicknet Ethernet, right, where you had a single piece of coaxial cable and everything was strung off that single piece of coax, that everyone heard it. They saw that MAC address, whether if that was traffic they were interested or not, so they either accepted it or dropped it, that it just starts sending. So it's all on the wire, right? And when we go to IGMP snooping, we'll see there's an improvement to that, but they're just getting the traffic, okay? With IGMP, a receiver gets to tell the router, hey, I want this traffic. And the switch using IGMP snooping, it knows this port wants that traffic, and it's going to make sure it gets there. If the source is on the other side of the router, that's where IGMP becomes very important. That router needs to know, I want this traffic. A receiver, you think a traditional receiver, think of a radio, right? Punch up the station you want to listen to. You don't inform the station, I want to listen to your radio. You just start receiving the traffic, right? You're pulling it out of the air. And this is kind of like that, but the router needs to know to take that traffic. So that's where IGMP comes in. 3 versions, version 1 in 1989. So from 1985, 4 years to develop. Almost 10 years later, 1987, IGMP v2, and then v3 was developed, came out the same year with some interesting improvements. Multicast listener discovery is that on v2, on IPv6, and you'll see that they already took because IPv6 that was developed much later than IPv4, they took the improvements of IGMP v2, made that their initial base. So MLD version 1 is the same as IGMP v2, and MLD v2 is the equivalent in IPv6 for IGMP v3. Okay, we get a little details. So v1 is pretty simple. It's all about reports and queries. If I'm a host and I want the traffic, I can make a report. I want this traffic. You do it with the GTL at 1, so the router's not going to route it. It's taking it in because it's controlling the multicast from outside. And we'll get more in detail with that. A query is, that's the router saying, do y'all still want this traffic? So it's on a timer, and it will send out the query, and it's checking in. Every device that's listening for multicast has a random timer. So only one of them needs to respond back. And in the old shared Ethernet, the idea was that we all heard that report back from the one host. So our timer was longer, so we said, great, and just stopped. And the host suppresses the reply. Only one needs to report back. They just keep telling that router, yep, keep sending that traffic. I want that group. And you notice this IP address, there's a couple things we mentioned yesterday that in the range, that 00, those are always link local. They always come out with the GTL at 1, and the 224.001 is all IGMP devices, all multicast devices. So everything listening to multicast is going to send a query. Hey, do you still want these groups? He's going to report back saying, yeah, I still want that group. These guys want that group. They're going to do it. If it's the only group running, we're done. If there are multiple groups, or because he sent a query that if he sent a generic query that everyone's going to report back, yeah, I still want this group and I still want that group, that you'll keep letting the router know so it doesn't kill the traffic. If nobody responds within backup timers, it's going to stop sending the traffic on the LAN. Because if all my listeners have shut down, you've closed your multicast application, why would I want to continue to just put the traffic on the LAN? It just wastes resources. That's the idea. With V2, the big thing they did was now if the old one, in between queries, if all the listeners shut down, nothing happened until the query interval. So then the query goes out, the query isn't answered because no one wants the traffic anymore. And then it's going to go through some timeout, then it's going to kill the traffic. And that's a CCIE question somewhere in there in the written, if I remember right. That's a CCIE level question. It's going to ask you about, and you want to dig into detail. Cisco's got 2 good books on multicast. They're available, I believe, both of them on the O'Reilly website, which is great subscription. Your tech stuff keeps you from having 30,000 pounds of books in your office, which you can see I have 2 bookcases full of stuff, but it's not all tech stuff. Actually, not a lot of tech stuff. I've really gone digital as much as possible, right? What do you do in the old versions, right? Anyway. So the idea is that we will stop forwarding when we get this leave message now, and it's sent to another special group. So you can look that up on your IANA charts, and you'll see 224.002. That's all routers, all multicast routers. So because I'm not necessarily sure who the router is, I want to let all routers know, yeah, I still want this traffic. Multiple routers in a segment, they elect a designated router, so the one who's going to handle all the joins. They'll deal with it, so other routers receiving this leave, they don't need to do anything with it. I'm not already doing any forwarding for that group. I'm just going to ignore it. Now, it may help me delete out of outgoing interfaces, something like that. I can see there's some use to it, but this also keeps all the other routers informed. Okay, so and then there's a query that's going to come back. One host sends a leave message. There'll be a query to the rest of the host to make sure that the other host still wants the traffic. And if they report back, I'll keep sending. The router will keep sending. If not, then I'm going to kill it. And you'll see with IGMP snooping that we suppress leave messages. We let the switch actually take care of that. And there's some real good use to that. V3 adds a really important, it's called source-specific multicast. And in that one of the things I mentioned yesterday is it's called hijacking, right? So in hijacking, you can, I'm sending on the same group as someone else, and I'm using the same UDP port number, they may get my traffic. And apparently, someone tells me a story from the early days at Cisco. Apparently, John Chambers was doing, I guess it was John Chambers, was doing some sort of presentation, and somebody else had picked that multicast group and was doing a little play chat amongst themselves. So people tuned in to get something, and they got them instead of the CEO. You know, and I'm sure there were phone calls, get off the, you know, quit it, you know, get on the call, right? So, and there's a new group because we're now running IGMP v3, so we want to do what's v3 capable. And the big thing is I can now include or exclude sources. So when I'm a listener, so these are receivers. Remember, we're really dealing with the IGMP, as I said right at the beginning of this, the IGMP receivers are all, IGMP is really about receivers, not senders. So this receiver can say, I can exclude no, which means I want everybody. I can exclude these, so anybody but that, I can do an include. And in some types of IGMP v3 traffic, there are things like your application can tell the host, because this is all going to happen out of band. There isn't, inside this, there's no magic that says, yeah, you want to ask for this source. It has to, that happens all out of band from this. So, you know, InformaCast with Cisco phones, where you can do group paging off the speakers on the phones, you can use IGMP v3, and then InformaCast needs to be able to say, yeah, use this group and this source. And there's some advantages when we start seeing how IGMP really goes to work of v3, of source specific. It saves some complexity to an extent, but it now shifts some of the requirements back down to the application. The network isn't doing it so much anymore. Okay. And I can, like I said, I can include a particular host. So I want traffic for that group coming from that source. So you see the first one, that's in that class D range. That's going to be a destination. The include, that's a source, that's a class A address, right? And I'm sending it to a class D address, and it's that special range 224.00/24, where it's link local. BTL01, not supposed to be routed. So it's talking to the router. It's going to say, please give me this traffic. And again, it's doing some queries and reporting to maintain the connection. Do you still want this traffic? And there's a timer, because a source is a receiver, excuse me, is passive. A source is sending, and it just sends. Receiver is receiving. There is no bidirectionality to this. There is no, it's UDP, right? So we talked about that early on in part one. There's no acknowledgments. There's been no handshake. So somebody's got to keep checking to say, should I keep putting this traffic out on the wire, or should I drop it? This is where I start to talk about IGMP and MLB snooping. So see how I said it will not forward these IGMP and V1, V2 reports to any other hosts, only routers. So remember we said that when a router queries, the host reports back, and there's backoff timers. So as soon as they hear one host is replied, they'll all shut up. There's a good reason they don't want those other hosts to hear that reply. So to know which ports are supposed to get that multicast traffic, I want to hear their replies. I want to hear their reports. Switch. I'm speaking from this perspective of the switch. That they want to hear that so they know, ports 1, port 7, port 32, those all want this traffic. So I will continue to switch them that traffic. And so I said yesterday that in layer 1, if it's coming in layer 1, you have no choice to receive the traffic. The electrical signal, the wireless radio frequency energy, the optical light, the blazer, however you're transmitting that signal, you don't have any choice. In this case, with snooping, the switch is going to say, I'm not going to send this traffic down links that don't need it. This is great if the multicast streams are high bandwidth. This is super awesome because, and think about it, if you have a mix of devices, now you even have multi-gig technology, right? You may have, on one switch now, you could have anywhere from 10 megabits per second to 10 gigabits per second. For 10 gig, even a 1 gig signal is not that big a deal. It's 10% of its length. It's the entire length for a 1 gig port. It's 10 times the length on a 100 meg port, and well, it's 100 times that 10 meg port. So I can say not going to send it down those ones. It proxies the querier function. Now it fakes out an IP, source IP when it does the queries because it doesn't want to confuse the device if there's more than one querier. And it's only going to be querying other hosts, not routers. And the switch proxies the reports back. So it gets a leave. The switch knows this is going to be V2, right? Leaves don't exist in IGMP V1. In V2, it hears a leave. It can say, I'm going to take that link out of my outgoing interfaces, out of the ports that I'm going to be delivering this traffic to. It may then query the other ports that are on that group to make sure they're still interested. But the router doesn't know. As long as this switch still has ports that are interested in that traffic, it's not going to allow a leave to come through and hit the router. So it's relieved some of the pressure from the router. So IGMP snooping is actually really useful. It helps reduce at layer 1 traffic going to ports, because if there's any question around multicast traffic, it's going to get flooded. You don't want to flood. If you don't have to, then it's a broadcast. It's not really a multicast. It's slightly better than broadcast, yes, because the receiving host, the MAC address that goes, hey, I don't want this MAC address. If for a reason, because of that oversubscription we talked about yesterday, that MAC address, it's going to see the destination group and say, yeah, I don't want that. That's not the traffic I actually wanted. And so it has a couple of opportunities to drop it. But this way, it's dropped at layer 1. So the other way you're dropping it at layer 2 or layer 3, we're going to drop this is able to drop it out of layer 1. And again, I wanted to show you the components. So we just sort of now, like here we go, IGMP. We haven't talked about multicast source discovery protocol multicast. Right, we just got there. We've talked a little bit about layer 1, layer 2, layer 3. So there's now a bunch of components we can put together to start putting together a basic network. So at this point, with IGMP alone, and by default, IGMP is typically turned on Cisco switches. However, if you want version 3, you need to turn that function on. You need to turn that on. Identify this port is going to be running IGMP version 3. Okay. They're still not routing multicast traffic because by default, multicast routing is turned off. Okay. So we definitely have some time for some questions in today's, let's see how we're doing on time. I have a watch, I'm not using it. Feel free to ask questions. I've got the chat window open. And then here's some questions for you as you start trying to look into this. If your traffic just local, so a lot of what I'm going to be talking about going forward, if my entire multicast consists of RIP v2 exchanging routing tables, you don't need all this, right? Certainly be aware of what the group address is, because you certainly don't want to put an ACL on the interface and block that traffic. Otherwise, it's not, you're not, that you want to be receiving those RIP updates, right? So is it the traffic you want? Is it in a single site or campus, right? So is there a WAN boundary or not? Does it need to cross the WAN? Maybe not. If it's crossing the WAN, there's questions like, does my provider support? So if it's a layer 3 connection, that's really important. A lot of layer 2, not so much, but even with some of layer 2, they may put limits on it. So if you have a multi-point, they may put a limit that is less than any of your port committed information or permitted information rates, right? What PIM mode are we using? Am I using now? Or what do I need to use, and will it change? So we're going to talk about that more in detail, but you can start to look at it as you see your SVIs on your switches. You're going to see IP PIM mode, sparse mode, IP PIM dense mode, IP PIM sparse dense mode. And what does that mean? We're going to get into more of that in the next class. And of course, this is an important question. Does all my hardware support multicast? That needs to. I had to put that as an. So there are some things. The entire path has to be multicast capable and multicast enabled. And there's a little bit of fudge on that one. So say I have one of these dumb switches on my desk because I don't have enough structured cable in my building, so this is how I can hook up a couple devices. As long as the switch doesn't, that little cheap no-name switch doesn't interfere, you're fine. There'll be some things happening here that would be a little different. So if I have multiple devices and they're all subscribed to a group, one leaves, yeah, they're going to hear that leave message because the snooping switch is going to be up one layer from, or is going to be up one hop from this. So they'll act a little differently than if you had your own dedicated switch port and the switch did IGMP snooping. Okay. But from that first layer 3 interface all the way across, somebody doesn't want to do multicast, you got to find a way around it. There are ways around it, and that's going to be in the advanced topics. That'll be a couple of weeks, really, before we get to it, but there are ways around it. But these are the kind of things that are great to look up. The other thing about that hardware support is you may need to go look at license levels. So I suspect a lot of Cisco LAN Lite, which is their totally entry level, they're going to give you very little capability, if anything. And in some cases, you're going to need to do what used to be things like enterprise services, IP services. All of the naming is changed around a bit. So you're going to need to start taking a look if it's PIM capable, if it's IGMP capable on their requirements for your hardware. And so if you've been given a task and it's going to be like deploying IP phones, you want to use the InformaCast function. So that's multicast, or you're deploying Vocera, which is, if you haven't seen it, love it in hospitals. It's a little fob you wear around your neck, and you press a button, you say call such and such, and it's voice communication. Their hospitals love them because the ward nurses, when you click that button on the side of your bed and say, oh, nurse, I need some, can I get some more pain meds? I need some water. I need to go to the bathroom, whatever it is. They don't have to be at the desk to get that signal. In the old systems, it was wired. You had to do that. Somebody had to be at the desk and pick it up and go, yep, I'll be right there. Or I'll send somebody over. The way it is now, that they can be out helping a patient and the thing will come through, nurse, can I get some water? I'll be right there. And multicast is involved where they do groups. So they send a code blue. I need to have all my alert team to show up to deal with this patient in cardiac distress, that they all get notified simultaneously, and it's one stream because it's multicast. Yay! So you got to know, hey, does my wireless support multicast? These are all things you got to look up and understand. So you're going to start digging into what applications I have, what's their scope, right? Is it like really, if it's a server on the same LAN, and I mean same VLAN, same segment, there's not much I got to do. If everything's going to be in that one little LAN, it's handled, right? But the moment I start to route, then I have to know, if it's a multi-layer switch, can it do it? So start collecting all this data, and certainly if you have questions, you can ping me. I'll be glad to answer what I can within reason. Okay. Thanks for watching. You can subscribe to my YouTube channel. Yeah, that's not a very friendly. I think I have to have so many subscribers, and I could get a better version. Cut and paste. Sorry. And I try, and if you follow me on LinkedIn, you'll get the links to the YouTube channel from there. Twitter, a lot of politics on Twitter, but whatever. And then you can also follow me on Facebook. You don't necessarily friend if I don't know you. I don't typically take friend requests, but you can follow me and find announcements there as well. Feel free to suggest topics in your comments, and ask me whatever you like. There we go. Thank you much. I'm not seeing any questions right now, so I'm going to go ahead and stop the recording and stop the call until tomorrow. So I'll see you at 9 a.m. tomorrow, Pacific time, Pacific Daylight Time. And hope you're washing your hands. Hope you're taking care of yourself and your loved ones. Wash your hands. Don't touch your face. I managed to make it, I think, the entire call. You'll tell me I didn't touch my face. It's easy. Scratch, whatever. It's easy to do it, hard to stop, but it's important. And remember, you're not doing it just for you. You're doing it for the people around you, right? You pick it up, you transfer it to somebody. You have no idea if they're immune compromised, if they're a lifelong smoker, and that's going to make them more susceptible to a really bad outbreak, asthmatic, the elderly. We're washing more, we're washing our hands, we're staying inside, we're doing all these things for them. And we're doing that too to keep our doctors going, because they're short on supplies in a lot of places, and the more people that present in those emergency rooms they have to care, the quicker the supplies run out, the more likely they're going to get sick. And if we get sick later in this and it takes them down, that's going to make it even worse because there are fewer people to help. So do your part. Join my calls. I'm trying to make this useful. It's a little heady, but it's a great start. Thanks for listening.